Alright, hello. Right now I'm going to just go through a couple things. I made a Flappy, pretty much Flappy Bird using the Windows console. So this is in C++. If you don't know C++, that sucks because it's better than everything else basically. No, but I used some of the Windows API. I will be coming out with a tutorial on that hopefully soon. Um, so if you don't know Windows API stuff, there's a ton of tutorials on pretty much anything. But pretty much these are, I made a couple variables here down, where are we? So here, this, I didn't actually make this obviously because, well, it just is formatted weird. But this function clears the screen, the Windows console screen, and I will go into how it works more in depth in another video, but it's relatively complicated. So how my program works is it takes a screen and refreshes it every so often, and it'll take in your input, which is I made it the space bar. And so pretty much it just checks if the space bar is true or false, and then it will either have your Flappy Bird thing, which I didn't want to mess with different characters, so I just made it an asterisk. It'll choose if that goes up or down, and it'll check if your Flappy Bird hits one of the poles, which are X's. So here, just to have you get a little bit better idea of this, I made it just so you have to type in something at the beginning. It's really terrible. I could have made it, architected it differently to make it a bit better, but it's definitely a work in progress. I was just testing stuff out with the console. Objects are hard with the console because the deleting function that I'm using deletes the whole cache that you're using for your DC interface. So if you don't know what any of this stuff is, I will probably come out with a tutorial soon on the Windows API and Windows console stuff. So anyway, let's get into it. So I just obviously declare some variables here. Oh, so up here, I just did a little bit of experimenting, and I figured out that on the standard Windows console that Visual Studio's 2017 uses, just how it naturally loads is a 29 line view, and so I made this to render the poles, obviously from the name poles rend. So interesting thing. So these coordinates here that the DC uses require shorts for them to really work. And down here, let's find it. Oh, here. So yes. So setting the cursor for the console, it requires shorts. Well, shorts from the chords, but so if you're not very well versed in C++, how most of Windows API works is it introduces a bunch of new quote unquote variable types. They're not really different variable types, but they're just structures that like this HSTD out is just a handle structure that they're using. That, I mean, it's not technically a variable type, but it's pretty much variable type. The chords used by the DC, they well, are just pretty much a structure. But if you're wondering why I'm saying DC, that is the memory location, like the memory location stack of your of the console application. So in your uh, processor, it when you launch it, it allocates a certain memory stack to your um, console. So this all of these Windows API commands and stuff that I'm using, like this, and if you go into how into the Windows API H files, header files, you'll find all of this stuff defined. But anyway, so these Windows API, all this stuff that I'm using is just going into the DC file system. And if you are relatively like not a beginner programmer, you will understand after I go through this a little bit more that my program is architected terribly. I really should have used some objects for your Flappy Bird and your polls and all of that stuff, but I didn't, and I am making a a visual version of this pretty much that will use objects because I'm not dumb. But anyway, let's get into a little bit how this actually works. So I have a loop here. All my variables are defined up here. I can put a like pretty much just copy and paste this into the description in my video, hopefully, if I don't forget. But anyway, so or put like a link to it or something. So this just is looping through the screen. If we scroll down here, so the screen refreshes. This clear screen function is the one that we saw down here earlier. That just clears the screen like it sounds. But so it just loops through, and here let's discuss a little bit of how it actually works. So this Flappy POS, I believe, it has the Y coordinate pretty much going down from the top of the position of your Flappy Bird. Now, going down from the top, because of how the DC works, it has XY 0, 0 being top left corner. And so this is just counting up, like so, first row 0, 1, 2, 3, 4, 5, going down. And so that's how that works. And then I have this XPOS, which has the X position of your poles. So it's going to, in my very poorly architected program, it's going to just move the XPOS every time it refreshes. It moves the position of your X one to the left. So it just subtracts one from it, and this is how it generates the poles in the proper position. So we also, where is it? Maybe it's not defined here. So we have a concept of ticks, which if you do very much programming, you probably know what ticks are, especially if you do real-time stuff. But like a ticks would be time increments that we're using. So we do ticks. Where's our tick counter? So we do a tick every increment. And if you saw in the top left when we were running our program, there was a little, well, here it is. So we just did cout ticks divided by 10. So there's like a lot. Each time it prints out is roughly, like each time the status changes in the top left, it's about 1 second. So that means that each of these rotations, it refreshes about 10 times per second. So now if we go through here a little bit more, so we have our we didn't our subticks are for something else, but so here we have all of our stuff initialized. If you don't know very much about programming, I would suggest you learn a little bit more because this probably just looks like gibberish at this point. Like it really, you need to know basics pretty much. But even if you know Java and not C++, it's pretty similar. Like I'm not doing any memory management stuff actively like the Windows API does, but I'm not doing any actively in my program. So you don't need to know anything about that. If you're wondering why I'm saying this, Java doesn't have memory management open to you, but C++ does. It's a minor thing. You don't have to use it very much unless you're doing like visual stuff. You kind of need to use it. But anyway, so we are up here. We are printing out, obviously, like I was just saying, ticks divided by 10. So just kind of a counter to see like how long you survived pretty much. And then this Flappy chords, we are assigning, if you look up here, Flappy chords, it's one of the coordinate quote unquote variables. But we have, I just set it to 20. I probably should have had a different variable position that I use to assign this, but anyway, so it's 20 just because, like, if you've ever played Flappy Bird before, your bird kind of stays in one position of your screen and then your screen moves. So that's kind of the effect that I'm trying to have here. So I have the 20 here and Flappy Paws, which, if you remember earlier, is the Y position of your Flappy from 0 in the top. And so then here, this command here, it just sets your cursor in the DC to this position. You don't have to worry about that. That's a little more complex. I'll probably go over that in another tutorial sometime. But so this is just using the XY coordinates of our Flappy chords. So it's just moving your cursor there in the DC, and then you go see out asterisk. That's our bird. So here we have this whole thing is our generating, or not our generating, well, yeah, our generating of the pole coordinates. So I wanted to do this kind of a random generation so that it wouldn't well, I mean, it gets repetitive, but not like super repetitive. So this here we have, if you don't know what %% is in programming, it's dividing, like integer wise, dividing it, and then if there's a remainder. So what we're saying is if our tick counter divided by pull time, which pull time is a integer up here that it just counts for our pulls. Anyway, so our pull time equals 0. So if the remainder of ticks divided by this number equals to 0, then we're proceeding in here. So we're just initializing pull IND indicator, which is Boolean obviously, to true. And so that's just going to be pretty much a check of down here. If you look, this resets. Well, so here, when it gets and touches the left wall, it's going to make it so the pull IND equals false, and then this here will stop calling our pull rend function, which, if you keep watching, I will go over it in just a minute. So here we have xpos equals pull time. So our x position and pull time are syncing. So yeah. But so anyway, make pipes bottom. So this I neglected to kind of talk to you about it a little bit. If we go down here, we have our x pos minus minus, and oh man, where is it? Okay, well, so I will find it in just a moment. We'll go over it then. But so we have just randomly generates our bottom pole, where our bottom pole coordinates are between 29 and 11. If you don't, this is pretty much just random number generator. If you want to see initialization of it, we have, this is setting up random number generator. I would, if you are new to programming, and if you are not new to programming, I would recommend you comment a lot. It is really helpful. If you do not and you're working in a group, everyone will hate you. Maybe not, but like it's a nice thing to do. Just even for yourself, going back and debugging, you can just make a state machine and just look through it. But okay, so now our top, this is not generating our top position, it's generating our difference between bottom and top. As you can see here, top equals bottom minus top. So then that gives us top and bottom. So now if we go back up to here, we're declaring our different functions. We have, well, that function, our clear screen function, and our pollRend function renders our polls, obviously, and they're voids, so we don't have to return anything. So here, this doesn't, like, this stuff can really be kind of in whatever order you choose, but, or in whatever order, it doesn't really matter. But so this reinitialize pipes just goes back, sets these to 0, and it changes this pull ind to false, so then it'll stop rendering the polls at different positions. So now if we go down here, pull ind, if you just have it like that, since it's a bool, it's just true. If you didn't know that, it's a helpful thing. But then it just calls this. So now passes those. Let's go down to here. So what we have here is row ind and ind both short, because if you remember in our coordinates we have to have shorts, even though it says int, that's triggering. Anyway, it has to be a short, and that is why our xpos is a short. And so here, what I did is pretty much, well, this we don't really need to talk about it, but it's just a Windows API console thing. But so poll chords, we have our x position, which if you remember is x position of the polls, -5. So I decided that it was going to be 11 wide. So just arbitrary number, -5, and then we're setting our cursor position to this location, and now we just did some wacky stuff here. But anyway, so this how we're generating the top poll is we're going from the top until we get to the number of, like, the number of lines down that we want. So it's outputting x's, and I just got lazy, so I just did spaces all the way over to my, like, to where the poll is, and I mean that it would probably run a lot smoother if I didn't there. If you're watching this, I'm assuming you understand loops and stuff, but pretty basic stuff. And yeah, so now we're printing, probably don't need the find anymore because I changed it a little bit, but so now we're printing the bottom poll. So now we're putting coordinates. How I'm printing the bottom one is I'm starting from the bottom, and then well, I am going from where it is down, because so here we have our bottom and xpos -5 obviously, and so we're, if you notice, less than 11, we're just incrementing, having it 11 wide, and since it's a void, we don't need to return anything, and so life is happy there. We have polls. If we go back up here, now we have subticks equals 0, pretty much we don't even really need that variable. I don't really know why I still have it in here, but I thought I was going to use it. Didn't ever use it. Wasted like 8 bits of memory. Anyway, so now we have this loop here. Oops. We have this loop here, which detects if you press the spacebar. Could have done this a lot better with some software interrupt, but I didn't because I am bad. Anyway, so we just wait. It just loops through 10,000 times, whatever that is. 10,000 times does well. It waits. It sleeps for 0.1 seconds, which it actually only stops for about 1,000th of this because it can't really deinitialize and then initialize this quickly. So it just tries to stop, doesn't quite stop, keeps going. That's why it doesn't actually ever take. It doesn't actually ever get to that. Like it doesn't ever do its 10,000 waits of that long, if that makes sense. Anyway, so this is a let's go up here. So we import all of these libraries. We only use some of them mostly. There's some math libraries that we didn't really use, but we use a library to check if the spacebar is being pressed, and since this is a Boolean, it just checks. Then we set hop, which hop up here is equal to false. We set hop to true if the spacebar is pressed down, and then move Flappy commented this. If hop is true, it moves the asterisk up, and minus minus, if you remember, since top left is 0 0, since we're going up, and then else down, obviously. Then we clear our screen, change our tick value, and we increase X position. This is where we check to see if you died, pretty much. So if Flappy position is less than 0 or Flappy position is greater than 29, that's the top and bottom, you die and then the loop stops and it's over. Or if X position is less than 26 and X position is greater than 14. So that is okay, so that is pretty much the edges of the poles. So that is the closest edge to the left side and the farthest edge from the left side of the poles for X position. And then we have this if inside of it. We probably could have did this better, but anyway, as I was saying, poorly architected. But we have if it's pretty much just if this if it's outside of those of the inside of the pole, you die. So let's run it again and you'll see. Yeah, so as it renders, you can see it gets a little choppy. I believe that is because I do spaces all the way over. Like it would be a lot faster because it has to actually print out the spaces. So it would be if I was remaking this program, I would just have it do set the cursor to the position that I wanted it to. And if you notice in the top left, it's keeping track of our time. And so it is over. I hope you enjoyed watching. If this is good, please tell me. If this helped you at all, or if it was just interesting, thank you for watching. And if you have any ideas of other stuff that I should do, please comment it. I'm going into summer vacation, so I will have a lot more time. So I can make stuff.